Lesson 9.5, the distance formula in coordinate geometry. Now, so far throughout all our book, we have yet to touch coordinate geometry. You've done it before, hopefully, but just to review, coordinate geometry involves a coordinate plane, which is a two-dimensional system used to visually organize points of data, each position using predetermined distances from a horizontal and vertical axis. Points of data. What are points? Well, a point is a pair of two numbers usually organized as an ordered pair. Here's what that all means. Let's say that we had a pair of numbers. Let's say x equals 3 and y equals 2. Now we could organize this pair of numbers in ordered pair notation by actually, in parentheses, having x equals 3, but not saying x equals 3, just putting parentheses 3, comma 2. That is a point of data. That is an ordered pair. But rather than even writing out the numbers, we can plot this point on our coordinate plane. See, on this coordinate plane, we have these two axes, the x-axis and the y-axis. Well, since our point has x equal 3, if we count 3 spaces over on the x-axis, anywhere along that vertical red line there is where x equals 3. And if we count up 2 spaces on our y-axis, because y equals 2, anywhere along this horizontal red dashed line here is where y equals 2. So where these two red dashed lines cross, this point of intersection is the visual representation of the value of x equals 3, y equals 2. Now, let's try and figure out how to measure distances on a coordinate grid. If we were given this segment, say segment AB, and we were asked to find its length, well, to find the length of AB, we can simply count the spaces between these 2 points, horizontally speaking. So, if we count out the spaces, there's 6 spaces between point A and point B. How about segment BC? Well, if we count the spaces there on segment BC, there's 1, 2, 3, 4, there's 5 spaces. 5 spaces between B and C. Easy to count because B and C are nicely arranged vertically. However, what if I asked you to find the length of segment AC? Notice now that it's not easy to count the spaces between point A and C because AC is slanted. It's not perfectly horizontal or perfectly vertical. But remembering that we're in the Pythagorean theorem unit, you'll notice that this is a right triangle, so we can employ Pythagorean's theorem. A squared plus b squared equals c squared. So 6 squared is 36, 5 squared is 25, 36 plus 25 is 61. So c has to equal the square root of 61. This brings about the distance formula. Now, the distance formula at first glance may appear to be rather cumbersome, and it has a lot of odd-looking symbols to it, but don't panic because the distance formula is merely based off of Pythagorean's theorem, and it's just Pythagorean's theorem as it applies to coordinate geometry. In the distance formula, if we're given 2 points, say point A and point B, where A is denoted by its coordinates x sub 1, y sub 1, and B is denoted by its points x sub 2 and y sub 2. Then we can calculate the distance between these 2 points by plugging in the values into this formula, where the length of AB equals the square root of the quantity of x sub 1 minus x sub 2 squared plus the quantity of y sub 1 minus y sub 2 squared. For example, let's say that we were given the length GH, where G has the coordinates -4, 3, and H has the coordinates 5, -7. To employ this formula, we first need to recognize what x sub 1, y sub 1, x sub 2, and y sub 2 are. So, going to my 2 points, the x value in G is -4, so that'll be x sub 1. The x coordinate in H is 5, so that'll be x sub 2. The y coordinate in G is 3, so that'll be y sub 1. And the y coordinate in H is -7, so that'll be y sub 2. Now if we take all these values and put them into our formula, we'll take x sub 1 minus x sub 2, and that gets us -9. And that's just like saying that the length, the horizontal length between point G and point H is 9. Then, If we take y sub 1 minus y sub 2, we'll get 10. And that's like saying that the vertical distance between point G and point H is 10 units. So, taking these values, x sub 1 minus x sub 2, which is negative 9, and y sub 1 minus y sub 2, which is 10, we can put those values into our formula, square negative 9, square 10, we get 81 plus 100, which is 181, and square root it. And therefore, the distance from point G to point H is exactly the square root of 181. Thus concludes today's lesson.